Hey everybody, welcome back to HPC Tech Shorts, where every week we take you to the water cooler here in HPC Engineering at AWS. We talk to the engineers and the architects and the geeks who are making the cloud a better place for your HPC workloads. This week, I'm really excited to be joined by my colleague Angel Pizarro in Philly. Hey, Angel.
Hey.
Angel's our principal developer relations engineer on the DR team. And Evan in Barcelona. Evan, you are the CEO of Seqera Labs, the co-founder of Nextflow.
Awesome. Thanks a lot. Yeah, great to be here.
Hey, so very frequently I get in conversations with customers where they're considering lots of different things for solving their workflow problems. Awful lot of pharmaceutical companies, go through this discussion, and countless biolabs around the world, and obviously others too. Very often those discussions come back to building something custom on AWS, using things like step functions as a way to implement a workflow. But actually, in the end, what more frequently wins out, particularly in this scientific domain, is Nextflow. And one of the chief reasons for that, and this is one of the reasons why I love Nextflow so much, is it runs on nearly every platform known to man, on-prem, in the cloud, multiple clouds. And what it really does is a great trust builder with customers because it reassures them that their workloads are going to work anywhere on any kind of architecture. And then it also good separation of duties because it leaves us to just run a good cloud. We just need to keep coming and asking you what you need from us to keep building a better cloud. Did you, the scale that you've got to with Nextflow and with Tower now, the commercial solution that you're building on top of Nextflow, did you think that's where you were going to get to back in 2012 when you were cutting your first version of Nextflow?
No, I think the sort of growth of Nextflow has been pretty phenomenal, and definitely sort of outside what we were initially expecting. We kind of started off very much trying to solve our own problem, which was multiple sequence alignment. This was pretty back early in the day. We were running on a grid engine, Slim, sort of a cluster as well. Right. And we were submitting our jobs, trying to create permutations of multiple sequence alignment. Essentially, the admins were starting to get sort of a bit upset with us at the way we were kind of using the cluster, and we were looking for different options. And early on, so my co-founder, Paolo, the main developer of Nextflow, really came up with an idea of thinking about how we can submit the same workload, the same sort of pipeline, to multiple different execution engines. And obviously at the time, he became somewhat interested in the cloud, and AWS was really starting to become more prominent, although it wasn't really used for data workloads so often early on. So it was a kind of as trying to solve that problem from that angle.
Mm-hmm. And Docker, Dockerized workflows, like containerized, deployment. That was pretty new back in 2013, right?
Yeah, absolutely. So Paolo got the idea. He was watching a talk from Solomon Hykes, and this was back in 2013, so just after the release of Docker. And what he saw early on was like this idea that you could take containers, which were traditionally used for, or at the time were being used really for web services, and thinking about the data pipeline, not so much the whole data pipeline, but the individual tasks as containerized jobs, and sort of having that leap. It was very fortuitous moment in time that the way that the early design decisions were made in Nextflow, the idea that you have these individual tasks which kind of wrapped and independent of each other, that it was really fit the model that really came out. And then obviously that kind of foresaw some of the work like AWS Batch and other containerized executions.
Yeah, I think definitely this was a right technology at the right time. And you guys had something that hit the pulse of what everybody was looking for. And I think just for historical sake, it's worth mentioning that 2013 was very early. Like today, there are definitely workflow systems out there and choices for your bioinformaticians. I do think that Nextflow is one of the leading ones, if not the leading one that we see. But something that I want to call out about Nextflow at that time was that there were there's obviously always been workflow languages, and usually they were big, cumbersome systems that relied in insular modules encoded within. You had to be in this ecosystem of that workflow language. And the nice thing about Nextflow is that I actually called out to scripts and system calls, and it was really tuned for the way that bioinformatics works, which is really a file-centric and CLI-centric ecosystem.
Yeah, and separating those things out, I think, is very important. Like
do you think those were lucky decisions or inspired decisions?
Being perfectly honest, I didn't make them. So maybe, well, not many of them anyway. I was very much on the user end of it and an early tester at that stage.
Let's say with hindsight that they were inspired. It was
exactly
very inspired. So, bringing up the topic of other workflow languages, what can you highlight some of the differences and what are some of the strengths of Nextflow compared to some other things like CWL, for instance, or even things like Airflow, Apache Airflow?
Yeah, I think there's a kind of couple main differences. Firstly, we are, as you mentioned, in the bioinformatics space or HPC space. In that area, we started off in particular thinking about things which are generally file-based. That's a slightly different model than the kind of other workflow engines like Airflow. The main thing about Nextflow is it's a DSL, so it's this domain-specific language written on top of Groovy. This means that you have a very fast way of prototyping the pipeline, or essentially writing the pipeline quickly using the existing syntax. But if you're in a situation where you need to write something custom, some corner case, you can really access that under us. And that's, I guess, quite a contrast to something like CWL or WEDL, where it's really more of a specification. Main difference with something like SnakeMake or the Make approach, we're really got to push through here. So instead of defining your targets and then sort of having the workflow pull through, with Nextflow, you'll be able to essentially create the DAG initially, and then it can push the data through each of those tasks. We've seen that this is becoming more important with very large workflows. So we have customers who run from a single Nextflow execution over 1 million jobs. Now, if you need to build the DAG sort of before you start executing the pipeline with some sort of delays there, that can be a bit of a limitation. So a couple of other things that are different. Has like this self-contained approach where each task is in its own working directory. I say this was a design decision sort of mentioned early on. And I think the thing which I haven't seen any other workflow language do in the same way is this real separation of the workflow logic from the configuration. And I think that portability, that ability to really separate those two things out, is what really driven the community, because it means that everyone can contribute to these pipelines, and then from there, it's kind of led to that growth in itself as well. So it's many things.
And that's why we've got the emergence of something like NF Core, right? It's such a great library of workflows. That wouldn't have been possible without that really clean separation, would it? It would have been really hard.
Yeah, let's bring some, because pictures are worth 1,000 words. I think we've got a couple of really good illustrations of how Nextflow is structured. So why don't we bring that up real quick?
In particular, this.
Yeah.
Hey, can you zoom in a little bit? Actually, it doesn't matter.
Doesn't matter.
You can zoom in 1,000 times. It still looks like a mess. Whenever I want to try to explain to somebody what a workflow is, I just show them this, and I say Nextflow brings order to chaos.
Absolutely. So this is like a genome annotation pipeline. It was actually developed at Sanger Institute. And when I first saw this, I was pretty blown away. I always thought this is really incredible. But the most amazing thing is that this was able to be developed, written in Nextflow. All of those tasks were able to be containerized. Essentially enabled the execution to be defined and then run kind of repeatably across any different platforms. So we were pretty impressed to see this and kind of see what people started doing with Nextflow. This was actually very early on.
Let's pan over to the right. I think there's probably a little bit more of a easier to understand image.
So I think on here you can see like some couple of different visualizations of the same pipeline. This is an ancient DNA pipeline. It's been developed by folks over at NF Core, and here you can kind of get a feeling for the number of steps that each part of these workflows are made up of. We have customers who are running pipelines that are in that sort of 70 to 80 step range. Now with the latest versions of Nextflow, you can have pipelines and workflows, call other workflows. So that kind of expands your possibilities quite widely here. This is obviously a nicer visualization to understand, but you can think that now each of those single circles or oblongs in this situation is its own container. So we can define multiple containers for those workflows as well, which is starting to become a kind of more used model in this approach. And of course, then this sort of data can end up being multiple instances of those processes. So these could be tens of thousands of tasks get run through and used in this pipeline.
Mm-hmm. Yeah, and definitely being able to sort of categorize into larger boxes. So Nextflow introduced this notion of a new DSL, which allows modularization and easier writing and management of large pieces of functionality so that you can use it in other sorts of workflows. For instance, mapping and post-processing will happen irrespective of whether you're doing a regular germline or a somatic genome, and you can use the same piece of Nextflow configuration, that module, within multiple larger workflows, which I thought was really pretty cool.
So when did you, was it around about this time that you guys discovered Batch? Because when I look at the scale and the complexity of these pipelines, and I see how I imagine how they would map onto jobs, thousands, potentially millions of jobs spitting through an HPC cluster. If that HPC cluster was a shared resource, I mean, that you would just go mental. It'd take you days to get a single workload or a single workflow complete, right? So
yeah, absolutely. So we had some early ideas, and so we did enter into the cloud AWS space relatively early with a different iteration. It was a product, it was a sort of a solution using Apache Ignite, and this was a kind of a homegrown solution where we were creating an initial virtual machine, and that virtual machine was expanding and creating more EC2 instances within this Apache Ignite cluster. It was an early approach. It worked well, but it didn't scale massively. And it was really around that time when we started to see the limits of that, or really were pushing the limits of that Batch came around. We were drawn there from a user, eventually became a customer, who really kind of saw the potential of that and actually helped us write some of that early code. And as soon as we went to Batch, I would say that was really one of the other major accelerants of Nextflow itself. It was, I think, one of the first easy ways to allow researchers to really access the cloud in a way which spun up completely elastic, but also down to zero. And that was an important part for these kind of workflows, which are super heterogeneous. I need tons of CPUs now, and then I need nothing. And that was a really fantastic model, and continues to be a great model with the vast majority of our customers deploying in this way.
Yeah, it's no surprise. I mean, a lot of people who manage on-prem clusters so look at bioinformatics workloads as a pathology.
Yeah, exactly.
As a person who ran both clusters and used the cloud, I might have drunk the Kool-Aid a little bit. But that workflow portability really is a huge strength. And Brendan, you called to it when we first called out, why folks are interested in Nextflow. We'll strive to get researchers to go to the cloud because of our quality, not because of some lock-in constraint or anything else like that. And again, that assurance that you can take your Nextflow pipelines across on-premise and clouds is really a huge one. So that set of supported platforms is pretty amazing.
And the value, I think, is there's two other really big value adds there for users in this regard. One of them, if you think about just scalability, I want to be able to develop on my laptop. I really want to be able to run a small test data set on my laptop, developing it in my way. I don't want to have to set up some kind of complex environment to test this. And containers really enable that as well. Right. The other part of it is just pure collaboration. Many of these pipelines now, we have really commercial customers who are taking NF Core pipelines off the shelf. They want those pipelines to be maintained. Those pipelines will only really be maintained by the best of the best people in the world, so the experts, if they can really be deployed anywhere. And I think that kind of feeds into itself and creates a better experience for everybody as well.
Absolutely. And this is another one of those right technology at the right time for the right audience, is the fact that you guys integrate with Git directly. And that allowed you to do some really fun things, I think, and really user-centric things that are really nice for working and running Nextflow pipelines, is that you integrate directly with GitHub. And NF Core itself allows the community to submit their sort of, we should probably cover what NF Core is since we've mentioned it a few times.
Well, you've got a tab up there. You got a tab up there showing NF Core.
Yeah, absolutely. Let's get into NF Core. So NF Core is like really this community effort which sprung up sort of around one of the Nextflow conferences that we were holding actually not too long ago, right around the same time as Batch, maybe a little bit after. And then this was really a collection of people who were working in core facilities, hence the name NF Core. And they came together with the idea of how we can write pipelines towards some kind of standard way, but in a way we can kind of share some parts of the resources. There's common things which are common patterns which can be employed. And by using those, they make sort of all the pipelines work. The idea is that any NF Core pipeline, if you can run it on one infrastructure, you can run it on any of them. So they provide a kind of common config as well. The growth of this, I say, has also been really, really, really fantastic. Now there's something like 50 different pipelines. Again, mostly still in the life sciences space, driven by genomics, obviously sequencing technologies, imaging technologies is kind of big. There's also some proteomics work going in there now. But I would love to see something like this happening in other domains. I think like astronomy would be a fantastic one to start thinking about as well. We have some users, some sort of big users in there as well. So I think this model is really fantastic for.
What I love about the bioinformatics and the genomics community in general came to computing a lot later than the physics guys did. And physics guys still think that Fortran is awesome. It's the best thing in the world. And the bioinformatics community had no shame and just totally adopted new things and were willing to experiment. And that's what science is. Pipelines, right? Scientific research is actually just pipelines. It's all pipelines. Mm-hmm. You don't just run one job and there's your discovery. There's a ton of stuff you need to do to data to turn it into a scientific discovery. And
and the reuse of components. I mean, it's all about science is built on, the step before, and therefore pipelines themselves are built on, so many different pieces of software which you kind of rely on for building.
All right, so I want to see some of this in action. Let's.
Yeah, that's where I was going to go to as well. Let's go and show folks how Nextflow actually works in practice.
So far, I've kind of really just talked at a very high level about what Nextflow is sort of doing. Once you have a Nextflow pipeline, one of the main things is that you can run on any infrastructure. We've kind of made a big point of that so far, but I want to show you what that sort of looks like in practice to a certain extent. So here's like a local execution. Nextflow is there going to be running on, say, the host operating system with or without containers using local storage to a certain extent. So I can like run my Nextflow pipeline, Nextflow run, point it to a Git repository if I want, and then launch it in that way. A kind of main part of the portability, though, would be to be able to take that and then run that on a different infrastructure. So if we're going to run that, say, onto Slurm in this case, we have a concept of abstractions, and I think it was these abstractions which made it very powerful, all the portability. So if you think about something like a Slurm, you have a concept of a queue, you have concept of memory, CPUs, etc. And we wanted to keep those abstractions sort of concurrent across the different execution platforms. So I could take my Slurm execution, swap it out, the queue with my AWS Batch queue here, and then really run in the same way. I think that was that this model has been proven to be very successful and sort of very portable in that way. Yeah, so here's like a Nextflow config. You can see I'm defining a container here. I'm defining that I want to use Docker and kind of run on my local machine. I can then also, for the same pipeline here, like have AWS Batch. I have to define a few things. I have to define my queue, container, my work directory. In this case, it's an S3 bucket, and I define my region. I'm going to run this first with my local profile. So this is like a Docker profile I've created. And you'll notice here that this is a Git repository. So I could actually take this out, show you that this is the full repository, copy that in there. And here, this can work also with sort of any Git-based system, public drive as well. So connect that in there. I can put a version, a Git commit, a tag or something, and that will then go pull that pipeline from Git and run in this way. You can see that. And in this case, it's pretty quick. This is a simple pipeline for 5 steps. What I want to show you now is if I take that same pipeline, same RNA-seq pipeline though, and then run it in AWS Batch, I'm not changing any of the code. There's nothing which has been done there. I'm just changing the config to specify run in Batch. Take the same thing here. take out Docker and replace it with AWS Batch and launch now. This will submit Nextflow and the Nextflow tasks to the queue of my choosing. We'll spin up my virtual machines as they're required, and then go ahead in that way.
That there, folks, there's the magic. That's really cool.
I'll point out like one other pretty cool thing, which we were super excited about, and sort of how the way this works is you can actually split an Nextflow pipeline, and because the executor in this case is dependent on the task, you can say, okay, by default, run my stuff on Slurm, and then a particular task, say you need GPUs or you need some resources that you don't have on-prem and you want to go to AWS, you can then specify those tasks to use a big task. This will then run some of that code, say, on Slurm, on-prem, and then it will be able to burst the additional tasks into AWS Batch. It will upload the input data from those tasks to S3, to a staging location, run the tasks, and then take them back to your original location. Obviously, be careful here with the transfer of data, but this works kind of fantastically well for those sorts of situations. And it just kind of shows the flexibility of having this distinct separation between your config and your pipeline execution.
That is simply awesome. Okay, that's a feature mind blown. I'm sorry, I wasn't aware of that, and that is really, really neat.
That is very definitely especially for things like, if again, the hardware that you might not have available to you, like for instance, NVIDIA's A100, the fastest, latest GPUs, you might not have access to those on your local prem cluster or local workstation, and you might want to extend out only needing to use it like an hour a week. And in that case, it really makes sense to just farm it out and rent the thing as opposed to
or there's a global pandemic and you suddenly need to do a month's worth of work in a week, and you just need a crap ton more capacity. That's another feasible thing as well. How much sort of fidelity or articulation have you got over how the data moves there? I mean, obviously, like you said before, you need to be careful how the data moves in and out, because some of this is going to be regulated data. It could be private data. How do you manage that?
Also, just the size of the data is the bigger thing. I mean, many of these files are huge. I don't want to be transferring them around a bunch. But then it kind of works on the flip side of that, of maybe my data is already in the cloud, in which case I want to do some compute here, and I want to move the compute, which is exactly what's happening in this situation. So it kind of goes both ways. Yeah, and we're seeing, obviously, we believe there's going to be and maybe it's already happening, but there's going to be a switch where all the data all of a sudden will just sort of be in the cloud, and then that will become the default place. When that happens, we don't know exactly, but that's the kind of what we're betting on.
Well, I mean, you're enabling that, because the kind of conversations that Angel and I both have with customers, you must be having the same ones as well. Is frequently it's the headache of knowing how to orchestrate stuff between on-prem and the cloud. Everybody accepts that hybrid is pretty common and here for a while in HPC, but it's the headache of how to manage that interaction between the two sites. You've just created the machinery for that.
So this is some pretty deep technical detail. I think if folks really want to dive into the details, they could go to nextflow.io and look at the excellent documentation. And you guys have really, really fantastic tutorials that span completely new to Nextflow all the way to I want some advanced use cases. So I urge people to go there.
And of course, the NF Core to go and see the library of the workflows.
Right. Yeah. And that works really well for a bunch, our bioinformatics audience, our developer audience that is used to CLIs, command line interfaces, obviously. One more thing as we close out that I really wanted to highlight as very quickly. We've mentioned it a couple of times, this Nextflow Tower, and you're good enough to have queued up a nice a tab up there that I see. Yeah. Can you switch over to that? I want to show folks and show folks exactly what this is and what it's for and why people should care, I guess.
Give everybody a piece, because we're going to come back and dive deeper on this one in a couple of weeks' time.
Yeah, I'll give it 60 seconds. We're trying to address a few audiences, as I say, make the Nextflow ecosystem wider to people who maybe don't know so much about Nextflow. It allows workflow developers to, say, create workflows themselves to publish them, to create like custom GUIs based on a param schema, which is developed with the core folks here. It allows a lot of monitoring, so I can go into particular executions, watch them live as they come out here. So can, for example, view the tasks logs here, jump in, get information on aggregate statistics. Here I can see information on CPUs, total memory, estimate cost. I can even follow these tasks live. I also get information on very basic sort of track the individual tasks. So I could jump into these and I'll show that another time. We also have information on the resources that are used here. The nice thing about it was we tried to build it with the same kind of idea with Nextflow. And what I mean by that is that we wanted to support multiple different compute environments. So you can connect in here to your Slurm environment. You can SSH into it from Tower. And this is really much a customer deployed solution as well. So it's designed to kind of work in that way. But we can definitely dive into that at a future date.
I'd definitely do that. I mean, the fact that you've hit a couple of really big things there, it's like a single pane of glass for managing all of your Nextflow activity on any number of platforms, right? Cloud or otherwise. And you've also got all of the data that somebody needs to be able to debug a pipeline, because that's a common thing that pops up is how do I debug in this containerized environment? It's difficult, it's different, that's All right, we're coming back. You're not getting away too easily. In fact, maybe we can just record another one this afternoon. Let's keep it. Hey, look, I guess I should ask you. Is there anything else we really want to say before we close out?
Yeah, not so much. I mean, just in terms of what we're what we've got coming out with Nextflow and sort of what we're trying to do. I think there's still a lot of improvements to happen. I still believe this is really the beginning of cloud. We still see it. Yeah, we really see like still over 70% of our users that we poll are still sort of on-prem, although there's a big migration to the cloud. And I think that Nextflow users are probably one of the more, let's say, cloud-centric type. So really, it really is the beginning for these kind of things. I think there's going to be a lot of advances around the Nextflow pipeline development as well, the community side of it. We're seeing things like people wanting optimization of resources, smart storage, being able to click in and select into a lot of the services which have been built specifically for this audience now, which I think is really exciting. And as I say, we're really excited to be on as sort of part of this journey.
No, that's amazing. You guys are definitely changing the world. Keep us on our toes and make sure that we're doing all the right things to help you keep changing it. Thanks for both coming today. That was a really good discussion, and I'm kind of salivating and looking forward to the next one now because I want to get into Tower. It looks super cool. It's been a while since I've seen Tower up close and personal, so it'll be good to see it. Good to see it in action.
Thanks a lot, Wolf.
Yeah, thanks, guys. Thanks, Angel.
Thank you.
Now, last thing to say, if where is it here? If anybody's got any ideas about other things that they'd like to see us talk about on future Tech Shorts, our DMs on Twitter are open.